Hey everyone, Brandon with FastDataScience.ai here, and welcome to another episode of This Week in AI. This is the show where I cover trends in the news related to data science, machine learning, and artificial intelligence. And the trend that I'm going to focus on today starts with a question. What is the AI equivalent of peanut butter and jelly? For me, it's data science and machines. That is the relationship between the models that we develop and train using data science and machine learning techniques, and our ability to integrate those with machines that we interact with on a day-to-day basis. And probably the single best example of that is the Roomba device that's made by iRobot. So Roomba developed a machine that would automatically vacuum your floor. And over time, Roomba has started to develop ways in which to integrate data science into those devices so that those machines get smarter and smarter at cleaning your floor. Well, this trend isn't new by any stretch, and a lot of people refer to this as edge data science or data science on the edge. That is the ability to bring data science and machine learning models that traditionally require significant compute resources into the very devices that we interact with on a day-to-day basis. So it's not a trend and it's nothing new. So what exactly am I interested in talking about today? Well, what I'm interested in talking about, and it's really the title and theme of the show, which is the idea that Ameca meets GPT-3. And I'm sure you're asking yourself right now, what's Ameca? If you've been watching the show, you know a little bit about GPT-3. But Ameca is actually a robot that's pretty special because it's a robot that looks effectively like a human. And actually, this robot was developed by a company called Engineered Arts. And Ameca can do things and create experiences that feel to the person interacting with this robot as though it is very human. But Ameca, up to this point, hasn't been very intelligent. Sure, Ameca can look like it is doing human-like things, gestures, facial expressions, smiling, those kinds of things. But Ameca hasn't really been able to interact otherwise until recently. And that is when Ameca had GPT-3 moved and integrated into its architecture. So an experiment was conducted where Engineered Arts worked with OpenAI to integrate GPT-3 into Ameca, the robot. Now you have a robot that can not only act like a human using facial expressions and gestures, but can now respond like a human. The degree to which GPT-3 and the outputs of GPT-3 actually impact the gestures and the movements of Ameca, I think are still being developed and quite frankly are what I'm concerned about. It's really interesting to consider the implications here of making more human-like machines and embedding our data science into those human-like machine products, if you will. I'm not really sure what to call them yet. If you ever saw the movie I, Robot with Will Smith, it reminds me a lot of that. What's some of the data science that underlies the GPT-3 model? It really all has to do with this concept of embedding things or encoding things, the ability that we have to use machine learning to essentially learn numerical representations of different things like words. So here, for example, is an image that shows you what a word embedding looks like. So we can use a machine learning model to essentially train how to predict how one word relates to other words around it. Those predictions create weights in the model, and those weights are called vectors. When we add them together, those vectors, those weights represent different things or different associations that that word has to the other words around it in that model. We call these again embeddings or encodings. And encoding the concept of encoding things has expanded. Not only can we encode words so that we can relate them to other words, but now we can also encode words to relate them to images or to contexts. And that's the concept of transformers. That's where GPT-3 really has been quite successful, is that it uses an encoder and a decoder architecture. So when we encode a word like cat, we might also need a separate model to decode if we ask a question like, hey, what's a similar word to cat? So that it decodes and knows the answer should be kitten. So this encoder-decoder architecture is a crazy picture of it, but this comes from the original paper, Attention is All You Need, is really what underlies GPT-3 and particularly some of the multimodal foundational models that are starting to hit the market, like DALL-E 2 and some of those related data science trends. But let's get back to what I'm really concerned about, because it's not this ugly picture, and this certainly isn't a data science course. It's actually this crazy picture and this crazy picture here, which is the idea, again, that we are integrating now our data science, our foundational models, with these robots that look like us. I imagine in the not very distant future, Ameca will probably be able to take a request and draw you a picture. So I leave you with this. What do you think the implications are? How do we as humans interact with robots that can not only look and gesture like us, but also talk and respond like us? Does this have implications for consciousness? Does this have implications for intellectual rights? Does this have implications for other areas of society that I haven't even covered? So I want to hear your thoughts. I'm really curious to know what you think about how this trend might be affecting not just data science as a field and machine learning, but society as a whole. What does it mean for our future? Does it mean that we're getting closer and closer to what Will Smith experienced in iRobot? I don't know. So leave your comments, your questions. Talk to me a little bit about whatever you think the concerns are that I forgot to bring up. And so remember, don't just be data-driven, be data science-driven. And thank you again for viewing. Subscribe, share, and I hope that you got something out of today's video. Maybe it inspired you a little bit to think a little harder about how data science, machine learning, and artificial intelligence are really having an impact on our society. Bye, everybody, and I'll see you next week.